Have you ever thought about where your drinking water comes from or how much the United States uses each day? The numbers are honestly pretty hard to wrap your head around. The US uses approximately 322 billion gallons of water per day. Of this, 39 billion gallons are used for the public drinking water supply. Much of the US's drinking water is produced using processes like this one, where natural waters, like lake water, are treated using the following steps. Chemicals called coagulants are added to allow particles naturally present in the water to clump together to create larger particles during coagulation and flocculation. These larger particles then settle out of the water during sedimentation before the water is filtered. Finally, disinfectants such as chlorine are added to minimize microbial growth before the water is sent out for distribution to places like your house. During disinfection, disinfectants can react with natural organic matter, effectively dead leaves and other decaying natural material, to form disinfection byproducts. Many of these are potentially carcinogenic and are regulated by the Environmental Protection Agency. The specific class of disinfection byproducts that this research focuses on are trihalomethanes. Trihalomethanes, or THMs, are four compounds: chloroform, bromoform, chlorodibromomethane, and bromodichloromethane. But how big of a deal are these THMs? Between 2010 and 2019, the EPA found approximately 18,500 violations for THMs in public drinking water systems. Of these violations, 91% occurred in small drinking water systems. These systems serve fewer than 10,000 people. Studies have suggested that the high number of violations in these systems may be due to either a lack of technical or financial resources to implement removal or prevention strategies. But what can we do to help with this issue? Many studies have focused on methods of removing THMs that are less technically and financially demanding for small water systems. This study focused on membrane ear stripping with a hollow fiber membrane. You can visualize a hollow fiber membrane as a cylinder with a bunch of porous straws in it. Hollow fiber membranes are potentially appealing for small water systems because they're pretty easy to operate and fairly inexpensive. Membrane ear stripping of THMs is a process that takes advantage of the fact that THMs would rather be in the gas phase than the liquid phase. In membrane ear stripping, the gas flows through the fibers and the water flows through the cylinder or shell side of the module. When waters with THMs flow through the shell side of the membrane, the THMs then will selectively travel through the porous fibers into the gas phase. This results in an outlet gas stream with the THMs and an outlet water stream where most of the THMs have been removed. Our study found that for gas-to-water ratios above 30:1, the membrane was able to reduce THM concentrations from 200 parts per billion to below the standard of 80 parts per billion. This demonstrates that these membranes can potentially be used for compliance. While there's still much research that will need to be done to implement these systems, they may eventually be able to become part of a solution that will help with THM compliance in small water systems.